Right, for our next example, let's just run through our checklist again. So it's a right-angled triangle that we're trying to solve our problem for here. No, start that again. Right, so for our next example, let's just run through our checklist again. It's a right-angled triangle involved in our problem here, so we're going to be working with either Pythagoras' theorem or trigonometry. We've got two sides and one angle, so it's trigonometry that we're working with. So our next step is to figure out which function we'll be using. So we'll just write down SOHCAHTOA to make that easier for ourselves. We've got this side here, remember, is opposite the right angle, so that's the hypotenuse. I'm just going to shorten that to hype. And then the other side that we've got is the one that's opposite the angle that we're interested in. So I'm going to write that down there. That's the opposite. So we've got opposite and hypotenuse. And if we look up at SOHCAHTOA, we can see that its sign involves both the opposite side and the hypotenuse. So for our next step, let's write down the general formula. So that's sine theta is equal to, and then it's that first letter opposite over the second one, hypotenuse there. All right, so we've now set everything up. So now we need to plug in the values that we've got into this formula so that we can solve for our actual problem. So the angle is 40, so that's going to be sine 40. And then that's equal to the opposite, which we know is 5. And the hypotenuse, which we don't know, that's our missing value k there. Having got that far then, we now need to rearrange this equation. And this is a little bit more difficult than the one we had in the last example, but not too much because we can still follow all the normal processes we have for our algebra. The k that we're interested now is on the bottom of our fraction, and that's a problem because what we eventually want to get to is k equals and then some stuff on the other side. We can't have k equals if k is currently on the bottom. It's currently 1 over k equals, or 5 over k at this point in time. But basically what we're saying is we want to stop this being a fraction. We want it to just be a one-line equation. So, as we did in the previous example, we stop the fraction from existing by multiplying by the denominator. As soon as we multiply by the denominator, As soon as we multiply by the denominator, it went to being a single line equation with what was the denominator now on the top on the other side. So multiplying by k will give us k sine 40 equals 5. We still want k on its own. It's not on its own at the moment. We've currently got this sine 40 here. So treating that sine 40 as just a number, because that's all it is, we've got k times this number. Stop k being multiplied by that number. No, let's do that again. To stop k being multiplied by that number, we do the opposite. We divide by it. So we're going to divide by sine 40. That will leave us then with k equals 5 divided by sine 40. And so finally now you'll just want to put that into your calculator. You might want to err on the side of caution when you do this in your calculator and do the sine 40 first and then do 5 divided by the answer. Might make things a little bit more safe when you put them into the calculator. But let's do this. And you can check this on your calculator as well to make sure you're getting the right thing. I get an answer for that of 7 and we'll round to 2 decimal places, 7.78 centimeters.